Good morning to everyone. Myself, Dr. N. Narmadha, MSc MPhil, CA, PhD, Assistant Professor, PG and Research, Department of Computer Science, Sri Sharda College for Women, Autonomous, Salem 16. Today's presentation is about machine learning. Before we enter into the topic of machine learning, first we should know why we go for machine learning, why we use machine learning, and what is the importance of machine learning. To answer all these questions, human cannot able to handle a complex problem. Human cannot able to analyze the huge amount of data for finding the solution. In some cases, human decision may cause error. So for this situation, we have to train the machine to do the complex problem for finding the betterment of solution. So we are all know machine plays a vital role in our day-to-day life. Machine makes our daily lives easier to make decision. So this is the main reason we need machine learning for finding the right decision. So agenda of our presentation is history of machine learning, why we use machine learning, what is machine learning, how does machine learning works, feature of machine learning, need for machine learning, classification of machine learning, applications of machine learning life cycle, advantages of machine learning, disadvantages of machine learning, benefits of machine learning. See, history of machine learning. Before some years, about 40 to 50 years, machine learning was science fiction. But today, it is the part of our daily life, as I said earlier. So, machine learning is making our day to day life easy from self driving cars to Amazon virtual assistant like Alexa. However, the idea behind machine learning is so old and has a long history. Now, see, the diagram shows the history of AI, ML, and GL. AI, artificial intelligence, ML, machine learning, GL, deep learning. Actually, ML and GL is a subset of artificial intelligence. AI arose in the year of 1940s. ML started in the year of 1970s, and GL evolved in the year of 2000. Why we use machine learning? I already told. Human cannot able to find the decision easier. Human cannot able to find the uh, huge amount of data. So machine learning is used to make decision based on data by developing the algorithms on the basis of historical data. Algorithms find the patterns and relationships that are difficult for humans to detect. These patterns are now further used for future reference to predict the solution of unseen problems. See, here there is an interaction between the human and a machine. Human tells to the machine, I can learn everything automatically from experience. Can you learn? Machine replied that, yes, I can also learn from the past data with the help of machine learning. This slide shows the what is machine learning. Machine learning is a branch of artificial intelligence, as I said earlier. It uses computing based system, it extracting patterns, finding data to fictions, and classifying the data, etc. ML systems can learn and improve their performance easier with the help of historical data, time series data, and experience data. See, how does machine learning work? If we have a complex problem in which we need to make a prediction, instead of writing a huge amount of code, we need to just feed the data to generic algorithm which build the logic based on the data and predict the output. Our perspective on this issue has changed as a result of machine learning. So the diagram shows how does machine learning works. First, we need to input the past data to the machine, then train the machine learning algorithm After that, machine learns from the data. After training, building logical models, and finally it generates a new data. We called it as a output. Here, features of machine learning. Machine learning uses data to detect various patterns in a given data set. It can learn from the past data and improves automatically. It is a data driven technology. So, what is meant by data driven technology? So, data driven technology is a term used in many fields, but most commonly in the field of technology and business. So, actually, what is data driven? Data driven is an essential action taken by the ones that execute an event or process. This is the most evident in the field of big data, where data and information are the basis of all action and gathering and analyzing of data. Machine learning is much easier to data mining as it also deals with the huge amount of data. So, need for machine learning. We are all know very well. So, rapid increment of data, solving complex problems which are difficult for the human, and decision making in various sectors including finance, etc. So, finding the hidden patterns and extracting useful information from the data. So, here there are three classifications of machine learning. First one is supervised learning, second one is unsupervised learning, and third one is reinforcement learning. First one, supervised learning. Supervised learning is labeled data to build a model that understands the data sets and learn about each data. After the training and processing are done, we test the model with the sample data to see if it is an accurately predicted the output. For example, in the data, there is always a predefined outcome. For example, whether the data is right or wrong, whether it is true or false, whether it is 1 or 0, like that. So, supervised learning is capable of handling uh, uh, two ways. One is classification, and second one is regression. Second one, unsupervised learning. So, the training is provided to the machine with the set of data that has not been labeled, classified, or categorized, and the algorithm needs to act on the data without any supervision. The goal of unsupervised learning is to restructure the input data into new feature or a group of objects with similar patterns. There are not predefined and known set of outcomes. Look for a hidden pattern and relations in the data. So unsupervised learning is capable of handling two categories of algorithms, that is clustering algorithms and association rule mining algorithms. Third one, reinforcement learning. Rein- Reinforcement learning is a feedback based learning method in which a learning agent gets a reward for each right action and gets a plenty for each wrong action. The agent learns automatically with this feedback and improves its performance. In reinforcement learning, the agent interacts with the environment and explores it. The goal of an agent is to get the most reward point and hence it improves its performance very well. The robotic dog, which automatically learns the movement of his arms, is an example of reinforcement learning. So, here the applications of machine learning is here. So, automatic language translation, medical diagnosis, stock market trading, online fraud detection, virtual personal assistant, email spam and malware filtering, self driving cars, product recommendations, traffic predictions, speech recognition, and image recognition. Now, see the machine learning life cycle. So, there are 7 ways in the life cycle. First one is gathering data, second data preparation, then data wrangling, analysis of data, train the model, after that test the model, finally deployment. First one, gathering data. Identify various data source and collect the data, integrate the data obtained from the different sources. So data preparation can be classified into two ways. One is data exploration and data pre-processing. Data exploration, a better understanding of data leads to an effective outcome to find correlation, trends, and outliers. Data pre-processing is nothing but analyzing the data. Data wrangling. Data wrangling is the process of cleaning and converting raw data into an uncleanable, usable format. Converting a raw data into a usable format. In real world applications, collected data may have a various issues like missing values, duplicate data, invalid data, and noisy data. So, we use various filtering techniques to clean the data. Now, we are going to see about a data analysis. Data analysis is nothing but cleaned and prepared data is passed on this analysis step. This step involves selection of analytical techniques, building models, review the results. The aim of this step is to build a machine learning model to analyze the data using various analytical techniques and review the outcomes. To select the machine learning techniques such as classification, regression, cluster analysis, and association, etc. Then build the model using prepared data and evaluate the model. Fifth one, train the model. To train our model to improve its performance for better outcome of the problem. To use the various kinds of data sets to train the model using various machine learning algorithms. After the training, a training model is required so that it can understand whether the various patterns, rules, and features are properly visible. Test the model. So once our machine learning model has been trained on the given data set, then we need to test the model to check for the accuracy of our model by providing the test data set to it. Testing the model determines the percentage accuracy of the model as per the requirement of our projects or our problems by the users. So final stage in the life cycle is deployment. The last step of the machine learning life cycle is deployment, where we deploy the model in a real world system. If the above prepared model is producing an accurate result as per our requirement with acceptable speed, then we deploy the model in a real world system. But before deploying, we need to check whether it is improving its performance using available data or not. The deployment phase is similar to making the final report of our work or project and so on. So here, now see the various advantages of machine learning. Useful where large scale data is available. Large scale deployments of machine learning beneficial in terms of improved speed and accuracy, understands the non-linearity in the data and generates a function mapping input to the output. Recommended for solving a classification and regression problems, or already we know that. So ensures better profiling of a customers to understand their needs. Next, disadvantages of machine learning. Limited understanding of a machinery of a classifier like black box, requires a significant amount of data, so may not work in the case where data collection is difficult or expensive. Problem of overfitting if the model fitted on the small data set. So we are all know that machine learning works well in the in a huge amount of data set. It cannot able to work for in a small data set. So now see the benefits of machine learning. Natural language processing, recognizing images, data mining, autonomous vehicles, better advertising and marketing, better product, speech recognition, and detecting fraud. Thank you.
Learning. Teach a computer how to perform a task without explicitly programming it to perform said task. Instead, feed data into an algorithm to gradually improve outcomes with experience, similar to how organic life learns. The term was coined in 1959 by Arthur Samuel at IBM, who was developing artificial intelligence that could play checkers. Half a century later, and predictive models are embedded in many of the products we use every day, which perform two fundamental jobs. One is to classify data, like is there another car on the road, or or does this patient have cancer? The other is to make predictions about future outcomes, like will the stock go up or which YouTube video do you want to watch next? The first step in the process is to acquire and clean up data. Lots and lots of data. The better the data represents the problem, the better the results. Garbage in, garbage out. The data needs to have some kind of signal to be valuable to the algorithm for making predictions. And data scientists perform a job called feature engineering to transform raw data into features that better represent the underlying problem. The next step is to separate the data into a training set and testing set. The training data is fed into an algorithm to build a model. Then the testing data is used to validate the accuracy or error of the model. The next step is to choose an algorithm, which might be a simple statistical model like linear or logistic regression, or a decision tree that assigns different weights to features in the data. Or you might get fancy with a convolutional neural network, which is an algorithm that also assigns weights to features, but also takes the input data and creates additional features automatically. And that's extremely useful for datasets that contain things like images or natural language, where manual feature engineering is virtually impossible. Every one of these algorithms learns to get better by comparing its predictions to an error function. If it's a classification problem, like is this animal a cat or a dog, the error function might be accuracy. If it's a regression problem, like how much will a loaf of bread cost next year, then it might be mean absolute error. Python is the language of choice among data scientists, but R and Julia are also popular options, and there are many supporting frameworks out there to make the process approachable. The end result of the machine learning process is a model, which is just a file that takes some input data in the same shape that it was trained on, then spits out a prediction that tries to minimize the error that it was optimized for. It can then be embedded on an actual device or deployed to the cloud to build a real-world product. This has been machine learning in 100 seconds. Like and subscribe if you want to see more short videos like this, and leave a comment if you want to see more machine learning content on this channel. Thanks for watching, and I will see you in the next one.